So, in terms of zeta functions and maybe the Riemann hypothesis, the grand Riemann hypothesis, L functions, but just I guess L functions and zeta functions in general, there are many ways of going about trying to prove the Riemann hypothesis. Now, one way that I think is promising potentially is the Alencon, Caterina Canzani, and Henry Moscovici approach, which goes back quite a bit with Alencon, but they were able to get the trivial zeros based on just using a prolate spheroid and prolate wave operator, and they were able to exactly recover the trivial zeros. And that was very interesting to me, notably because Alencon in his non-commutative geometry, so in one of his presentations related to this paper, he said he's the alpha of x warping function basically in this geometry of his spectral triple. So alpha of x equals, I forget, it was a quadratic, something like 4x squared minus lambda, something like that. He goes on to embed this shape, this surface into Lorentz-Minkowski space, and I noticed that the similarity was that I was building this cone manifold, or just a more pointy version of a prolate spheroid. But anyway, the metric I was using was sort of like a wick rotated, sort of modifying the signature